Speaking of rocking, let's go ahead and get to that problem of the day. Says two cubes, we've already had some conversation about this on Facebook, by the way. Two cubes have edge ratios, we'll say that too, of 4 to 1. So that means basically we're looking at a cube and the edges are where the two faces come together. All right, not a point, not a vertex, that's a vertex point, all right? What would be the ratios of both surface areas and then of both volumes of those two cubes? So we're thinking small cube and a much larger cube. So let's take a look at this and see what's going to happen. First of all, cubes have all sides that are squares. So I could try to create a square. We'll see how it works. We'll try it. Let's see what happens, all right? Because those are what our edges are made out of. We're going to guesstimate eyesight here. We're going to hope we can do this right. And there goes a little bit of a box. We'll make a box out of it. We may have to retrace a little. Here we go. Box it off. We'll box off here. Pretty close. So in other words, we got one here that is, let's say this is 1, 1, and 1. All right, all the sides are 1. Now you say, well, Ernie, it said it's a ratio. Well, that's fine. We can do that also. But we can assign numbers here. But what's going to happen is you're going to make another square over here. There's going to be 4 times, in terms of the lengths, they're all going to be 4 times as large, all right? So my picture only can take so much room before it knocks me out. So that's what we're going to worry. We're not going to worry about that in case today. So what we're dealing with is surface area. And by the way, let's just think about this a little bit. You've got a cube. Think about rolling a die. All right, rolling a die, good old, what they call it, like a number cube. It's a die, all right? And we roll it out there. It's got 6 sides. They're all squares, and they're all the same size. So we're going to look at these things as being basically, there's area of 4 of these. So surface area, here's how it works. Here's how the surface area of a cube works. It's going to be, and we're going to use SA just for that. Total surface area is the same thing, all right? And we're going to get all those sides added up. There's 6 of them, and they're all squares, all right? And they're all the size of the edge squared, all right? Now the volume is 3-dimensional, right? So we're going to be talking about the length, the width, and the height. And remember, it's a cube, perfect on all ways and all sides. They're all squares, right? So all the edges are the same, which means your dimensions are all the same. So your volume is going to be equal to the edge cubed. Now that part's easy. This one, sometimes people forget, oh, we got 6 sides, okay? But you're dealing with area here, so this is going to be square inches or square feet. We didn't ask units on this. You can just make whatever your units are. These are going to be cubic because we're talking in 3 dimension. So let's go and take a look at this thing. Let's pretend we had an edge of 1. We're just going to play it that way because that's the deal. I could make it 2. But whatever I do, one edge is going to be 1, and another edge, we're going to let it be 4. 4 times as large. Now, what are we going to do? We're going to follow the formulas. And I'm going to pick up, first of all, the little surface area is going to be 6 times 1. Well, that was easy. 1. Ernie, where'd you get 1? I took my edge and I squared it. 1 times 1 is not 2. Don't do that. 1 times 1 is 1, all right? And these are square units. So this will be 6 square units. Now while we're at it, since I dropped my lower third out, thank you guys, we also have volume. And we've got volume, and this time we've got, 1 to the 3rd, which is still 1, right? Still 1. So we've got 1 cubic unit here of some sort, all right? So that equals 1 cubic unit. Well, that was easy, wasn't it? Let's go with the 4 over here. Surface area equals 4 times, what are we going to do this time? Oh my goodness, we got to play really hard here. No, we don't use 4. We use, what are we going to do with that 4? We're going to square it, right? And then we're going to multiply it times that 6. Formula says square it, then multiply. So we're going to take that. It looks like it's going to be 96. That's a pretty big difference, you know? 96, what is this? Square units. And our volume, how about it? Let's take it 4 to the 3rd power. And this is getting pretty hefty here. How about it? We're going to put 4 to the 3rd. That's going to give us 64 cubic units. Now use the word units once again because this could be centimeters, these could be feet, these could be inches, yeah. But let's start making some ratios. I've left us a little bit of space over here. Let's go back to the 4 to 1 business. Now remember, we picked the bigger one first, so we're going to kind of keep that ratio going. We can't switch the order. Since we've started 4 to 1, we're going to keep it large to small. Doing that, let's go to the surface area. It looks like we are at what? 96 to 6. And you say, well, Ernie, that's kind of like if that were a fraction, we could reduce, couldn't we? We certainly could. We could certainly reduce by 2. Actually, we can reduce by 6. So what is that actually going to come down to? It's going to be 16 to 1. So we now have 4 to 1 to start with. That's good. That was there, but it's not the reduced form. So we're going to go to reduced form here, because I want to show you a pattern here in just a second. Now let's go volume. My goodness, volume says what? 64 to 1. We can't reduce that one. So there we are, 64 to 1. Those are your ratios. Now, I want you to notice something here. This 4 to 1 was linear measurement, whether it be feet, my goodness, it could be yards, could be meters, it could be oh goodness, miles would be a big cube, right? You get the idea, inches, centimeters, all sorts of things. But what's going to happen is, as we work our way up, notice what we did. We took the ratio and we wound up basically squaring both numbers. That's how you can do it quickly, rather than having to go through all of this. It's nice you know the formulas. I use that just to show you. But it's really nice to realize that, oh, when we go to area, we're squaring. So we're going to square that ratio. It's going to work out. It's going to work out, my friends. Then going to volume, guess what? We're talking cubic. So we're going to be cubing the 4 and the 1, taking it to 64 to 1. And that is how you work with the ratios of similar figures. In this case, they were similar cubes. They had the ratio of 4 to 1 to begin with. That tells me that we can work that way. You can do that with circles. You know, you can talk about the radii, move them to the area. You can move into the volume of the cube, that kind of thing. So all of those things are little tidbits that make your life a little easier on that. Anyway, there's your problem of the day. 4 to 1, 16 to 1 for the area, and 64 to 1, for the volume.